The Gordon, Nebraska tornado, July 18, 2023. It was the departure day of our final tour of the year. It was time to head home. Guide Steve Pauly, Adam Lucy, and myself, Erik Burns, departed Rapid City, South Dakota around noon. As we left town, we noticed some storms over the Black Hills. Little did we know the effect this convection would represent later in the day. We headed south towards Chadron, Nebraska. We decided this would be a good lunch stop before making the haul to York for the night. After getting lunch, we noticed a large, beautiful updraft directly north of Chadron. Just because tours are over doesn't mean we are done with chasing. Oh no, we are greedy, and we want all the storms. We looked over some quick data and said, let's go. We met the storm at the South Dakota-Nebraska border, and it was exhibiting cloud-based rotation, but still a bit high-based. With no good roads, we had to backtrack and make a haul to get back ahead of the storm. We jumped on Highway 20 and headed east to Rushville, Nebraska. From there, we took a county road to Highway 27 and then headed south. We had to core punch the backside of the storm and took on some decent hail along with it. We cleared the precip and witnessed a strongly rotating wall cloud. While standing in the middle of Nebraska's Sandhills, we were treated to one of the most beautiful tornadoes of 2023, and we were the only 3 individuals on Earth who saw it. So what caused this event to happen? Why were there no other chasers? And why was there no SPC probabilities? Because this event is what we call a mesoscale accident, a series of events that led to the overall outcome. Let's dig in. Overnight, a mesoscale convective system moved across Nebraska. In its wake, it left behind a boundary that settled near Highway 27 south of Gordon. Moisture pooled along this boundary, and it was rich in surface vorticity. Remember those storms over the Black Hills we noticed as we left Rapid City? Well, they pretty much collapsed and set another outflow boundary to the south, towards the Nebraska border. This was the initiating boundary that our supercell would fire on. As the cell developed, it was going to move into a prime environment for tornadogenesis. Let's take a look at the incredible radar loop that showcases the chain of events. Then we'll dig into the specifics of this amazing event. Now let's dig into the storm relative environment. Since the tornado developed around 4:40 p.m. Mountain Time, we'll look at 5 p.m. charts from SPC mesoanalysis. Let's start with instability. Surface-based CAPE of 5,000 joules per kilogram, a very unstable environment. Next, 500 millibar flow. We can see a favorably timed wave with 40 knots of west-northwest flow in northwest Nebraska. At the surface, looking at one of my favorite plots, surface vorticity and 3-kilometer CAPE. We can see a very defined boundary loaded with surface vorticity with a bullseye of 125 joules per kilogram of 3 CAPE. The mostly north to south orientation of this boundary is very important for the southward motion of the storm. This allowed the storm to have ample residence time on the boundary to take advantage of the vorticity-rich environment. And now, significant tornado parameter. We can see an STP bullseye of 2 in northwest Nebraska. Here's a radar image of the tornadic supercell roughly at the same time of tornadogenesis. Now overlapped with the mesoanalysis 3 CAPE and surface vorticity plot. Once the storm crossed the boundary, it became marginally severe and collapsed as it moved into a less unstable air mass. Oh my God. That is so incredible. Whoa, man. Oh my gosh, he goes. Oh my God. Oh, wow. Wow. Holy. In the Sandhills. Thank you, 2023. This is absolutely amazing. Oh my God. I'm Erik Burns, Tour Director here at Tornadic Expeditions, and I thank you very much for watching.